Okay, we're going to go over the Holt pretest for 13.0. This is adding, subtracting, multiplying, dividing rational expressions. We did this in class on Friday, May 23rd. Number 1 says find the product. So actually, I'm going to show you on here. If we find the product, what we're going to get if you multiply straight across is x minus 3 times 2x minus 5 over 5x plus 2 times x minus 3. Now when we write it like that, we notice that every single one of these binomials is fully factored. In other words, they can't be factored anymore. Sorry, this is x plus 3. And none of these factors is exactly the same. So there's nothing I can do to simplify this. So this is my answer, but I don't see that answer here. And the only answer I can see that could possibly be the right answer is this one. And if you multiply this times this using Punnett square, 2 by 2 and 2 by 2, this is the answer you will get right here. Number 2 is 5x over x plus 2, and it says find the quotient, so that tells me it's division, divided by 3x plus 4 over x plus 2. Well, remember, when you divide fractions, you multiply times the reciprocal of the second fraction. So the first fraction stays the same. Our operation is now going to be multiplication, and we're going to flip this one over. The reciprocal looks like this. And when I multiply straight across, I get 5x times x plus 2 over x plus 2 times 3x plus 4. And I notice right off the bat that these two factors are exactly the same. So I have 5x, that's a monomial. If I wanted to, I could factor it like that. And then I have 3x plus 4. Now this is a binomial, it's a package deal. I can't factor this further. No factors in common. This is your final answer. Number 3 looks like this. It says find the sum. 4x over 2x plus 6x plus 3 over 2x. Okay, we're adding fractions. When we're adding fractions, we have to have a common denominator, and we do. Our common denominator is 2x. What's our numerator look like? 4x plus, since this is plus, it makes it a whole lot easier. We just bring over our 6x plus 3. And now I can combine like terms, and I get 10x plus 3 over 2x. Now, this is a binomial, and I can't factor it because there's no GCF. It's not a special case, and I can't use X-man. Now, this is a monomial. I could factor it like that, but it doesn't do any good because there's not a factor of 2 in my numerator, and there's not a factor of x in my numerator. So that's my answer right there. Number 4 says find the difference. 6 over x minus 3 minus 2 over x plus 3. Now, look at these two denominators. They're different. And this says subtract. Well, these don't have any factors in common at all. So the only way I'm going to get a new common denominator is to multiply these together. So my new common denominator is going to be this. These two multiplied together. Well, how does this become this right here? You multiply this times x plus 3, and that will give you this denominator. If I do it to the bottom, I have to do it to the top. How does this look like this? You multiply x plus 3 times x minus 3. And if I do it to the bottom, I do it to the top. Now, let's see what's going to happen. Go ahead and do our distributive property. So we have 6x plus 18. Now look, we're subtracting this whole thing right here. So what we're going to do is call this -2, and we're going to distribute it to every stinking term. So we get -2x. Now this is a really important part that everybody forgets. -2 times -3 is +6. So when we combine like terms in our numerator, and we get 4x plus 24 over x minus 3, x plus 3. Now, I don't see anything that I can cancel out, but I notice 4x plus 24 can be factored because I can pull out a GCF. Binomial, use your menu. So I have 4 times x plus 6 over x minus 3, x plus 3. Two factors, no factors are exactly alike. I could factor 4 and get 2 times 2, but that's not going to really help me at all, is it? And I'm looking at my answers, and I see this exact answer. And that's my answer for number 4. Number 5, find the difference. Y squared over y minus 3 minus 9 over y minus 3. I'm subtracting. Do I have a common denominator? Yes, I do. My common denominator is y minus 3. So I'm going to take y squared and I'm going to subtract 9. Now, this I recognize as the difference of two squares. There's no GCF, so the way you factor the difference of two squares is sum and difference. Y plus 3, y minus 3, and my denominator is still y minus 3. And you'll notice that this and this can cancel out, and I'm left with y plus 3 as my final answer. And number 6 says find the sum. 4 over x plus 1 plus 2 over x minus 3. We're adding. We need a common denominator. These have no factors in common, so I'm going to multiply them together, and I'm going to get x plus 1 and x minus 3. How does this become this? Multiply x plus 1 times x minus 3. If I do it in the denominator, I have to do it in the numerator. How does x minus 3 become this? I multiply x minus 3 times x plus 1. Whatever I do to the denominator, I do to the numerator. When it's addition, it's a whole lot easier than when it's subtraction, because when it's subtraction, we have to distribute that negative to everything. But I don't have to worry about that when it's addition. So let's go ahead and do our 4x minus 12. We're going to distribute positive 2 to every stinking term. So we get positive 2x. Don't forget to distribute that to that second term inside your binomial. So it's positive 2. A lot of people will multiply the 2 times the x and forget to multiply the 2 times the 1. Combine like terms, and we get 6x minus 10 over x plus 1, x minus 3. And I can pull out a GCF here of 2, so that would be 2 times 3x minus 5, double check, that's 6x minus 10, over x plus 1, x minus 3. No factors in common, so actually the answer that I see on that paper is this one here. Okay, I'm going to do 7 through 12 on another video.